System Design DoorDash. Hi guys, my name is Manish Kumar and in today's session we will create system design of DoorDash. So DoorDash is a food delivery service where user can place an order in a nearby restaurant and a dasher will pick the order from restaurant and will deliver to end user. So the biggest challenge in today's system design will be how to show the live location of the order to the user. So without any delay, let's start the session and see you in the session. Hi friends, welcome to my channel, and today we will create system design of DoorDash. So let's understand what DoorDash does. Basically the key requirement of this system will be user should be able to place an order from his choice restaurant nearby located. And the second will be restaurant employee should be able to find out dasher who can deliver the order. And the third will be user should be able to see the dasher location, and this will be live location, like where is my order. And what we're gonna keep out of scope is like profile creation, dasher sign up, and the payment details. So we will keep them out of scope from this video point of view. So I think we did good job on the functional requirement. Let's move to non-functional requirement now. So NFRs. So this system should be ultra low latency because user want to see the live location. System should be highly available. I want to place an order, but system is not up. This will be really a bad experience. So system should be highly available. So the third is highly scalable. So this has to be highly scalable system. And then fourth will be eventual consistency. So once I place the order, I should be able to see my orders, my historical orders. I think that's enough for NFR point of view. So let's go to step 3, which is capacity math. So here let's make some assumptions, which is like, let's say we have 100 million user base, and these user base are like including the people who are placing order, restaurant managers, and the dashers. And then we have, let's say, 10 million orders per day. And let's say we have 10 million dashers also who are sending the live location in every 4 seconds. And then let's say 1 million restaurant. So I think these are the few assumptions we have to calculate the capacity of our system. First, let's talk about the metadata. So metadata will be 100 million users data will be stored. And if let's say one user data size is 1 KB, which is 100 byte, and it's storing ID, name, location, and email and phone, payment details, which is 100 into 10 raised to power 6 KB. And 10 raised to power 3 KB is 1 MB, 10 raised to power 6 KB is 1 GB. So this is going to be 100 GB data. Orders data. So orders, we said we will have 10 million order per day. So 10 million, 10 into 10 raised to power 6 into, and one order size is also, I think we can make assumption here 1 KB. So this will be 10 raised to power 6 KB GB, so this is gonna be 10 GB per day. And then we have the dasher location. So the dasher location, for dasher location, we know 10 million users, 10 into 10 raised to power 6, sending their location in every 4 seconds, which means 24 into 60 into 15 times in a day. And if we say that the location data may be 100 byte, what will be the size here? So 15 into 60, it's 900. So let's call it 10 raised to power 3 just to simplify the calculation here. So we have 10 raised to power 12 into 24 byte. So now 10 raised to power 3 byte is 1 KB, 6 is 1 MB, 9 is 1 GB, and 12 is 1 TB. So this is 24 terabyte data per day. So metadata is also like continuously growing data, and if we call it, let's say we want to store 10 years of data in the history. So for 10 years of data, if 10 GB data per day, so within 100 days, it's gonna be terabyte of data. Because user, orders, restaurant, there is lot of structured data we are dealing here. So I will say RDBMS we should use. So maybe we can use SQL. We have to use master replica to make this scalable and highly available. So it's a heavy write, and because we have 10 millions order, so 10 millions people will be looking the live location in a day. So it will be definitely heavy read and write operations. And one data size is 100 byte. So maybe we can use DynamoDB here, which will give us a heavy throughput and highly available, scalable, sharding, partitioning as we need. And this will be simple key value storage. So DynamoDB for dasher location. So we talked about system capacity. We're gonna use SQL for the metadata, and we will be using DynamoDB to store the location. So now the time to talk about different APIs here we're gonna use. So in APIs, first will be post, will be order, place order. So user place an order here. So user say the user ID, order details, location, and payment. And order details contain the restaurant ID also, where the user is placing the order, or maybe I can add restaurant ID here. So before going down into APIs, I would like to talk about the Geo Sharding here. So what is Geo Sharding is? So basically what Geo Sharding does, it actually break down the entire map into small shards. So this is let's say this is a map. So system will break into small hexagons, something like this. So that's how it breaks the entire map into small shards. Each hexagon is a shard, and that has its own unique ID. So let me allocate a numerical number for each hexagon as an ID. So let's say this is 1, 2. So entire map is broken down into these shards, and each shard has its own ID. So how it works is, if let's say the user who is placing the order is somewhere in the shard 8 here, and here are different restaurants located in these shards, like one is located here, another is located. So let me draw these here, and I'll be back soon. So when the user who is located in shard 8 place an order, so system will draw a line of a certain diameter around this user to find out the nearby located restaurants. As you can see, one restaurant is located in shard 3, another is located in shard 4. So now user can choose the restaurant and place an order. So now let's go back to our APIs. So what this API will be having, this API along with location, it will be sending the shard ID also, the shard in which this user lives in. Next API here will be to find the dasher. So once the restaurant get an order, restaurant want to find dasher, where it will have it will pass a restaurant ID, delivery location, restaurant location, expected delivery time. Based upon this, the system again look in the Geo Sharding and find out the different dashers available near a restaurant. So if the restaurant in shard 3, user place an order, so what it will do, it will find out the available nearby dashers, send a message to dasher to deliver the order. Once the dasher accept the request, it marks the status of order is on the way. So the third API will be post order on way, where dasher ID, details and location. So dasher ID will help end user to see the live location for this dasher. So these are the key APIs what I think will be needed for this system. So now we talked about Geo Sharding, and so I'm moving it out here. So now it is, I think, the right time to jump into the design. So here is the user who want to place an order. So here one API we missed is like to get the list of restaurant. So it will be get API list restaurant, and that will be user ID, the one who is looking for the restaurant, and the location like lat long, and the shard ID. User will reach out to restaurant list builder to get the list of available restaurant nearby the location. So basically how this will get the list, we need to understand the Geo Event Cluster. So this is a Geo Event Cluster where servers are located in a hashing ring. So let me draw it, I will be back soon. So this is a hashing ring having all the servers located on it. Let's give a name to server. This is server 1, and I'll be back. Let me finish this. Here is the Geo Event Cluster, and each server here is responsible for a subset of these shards. So for example, S1 is responsible for shard 1 and 2, S2, and so on. Let me note it down for you and I will be back. So here you can see this is the Geo Event Cluster, which has all these servers located on a hashing ring, and each server is responsible for a subset of shards above there. So how the restaurant list will work, the user who is located in shard 8, and shard 8 is managed by server 4. It will reach out to server 4, and what server 4 will do, server 4 will draw a line around this user and find out the available restaurant and send the list back to the restaurant list builder. This will send back the list to this builder. Now the user has the list. Once the user has the list, so now user
will choose restaurant from the list and place a order. This is order service. Now order will be placed. Order service will store this in the database, and we already talked about different databases we're going to use here as part of capacity map. So it will place an order here. Now the restaurant manager will get a notification here, and it will reach out to Dasher service. Dasher service to find out the available Dasher. So Dasher service again go to the Geo Event Cluster and get the same way like I explained earlier. It will draw a circle and find out the available Dasher. Then it will reach out to the Dasher and Dasher will accept it. And now restaurant manager is good with it. So here will be a small service. I can say this is a ETA service, which is using the GPS location of Dashers to find out the ETA. And now once the order is ready and Dasher pick the order, one more thing here which we missed is like third user is the Dasher. Here is Dasher. What Dasher is doing in every 4 seconds, here is a location service. In every 4 seconds, this is reaching out to location service and sending its lat and long. And location service is storing that information in a DynamoDB. This location is used by the Geo Event Cluster. So that's how the Dasher is sending information continuously to this. And now the restaurant manager reach out to the service, which is order on way, and this service is continuously asking location service to know the live location and telling to user that your order is on way and it is at this location right now. So what order on way service is like asking what is the order location and sending it to user. Let's check the functional requirements quickly here. So user should be able to place an order from his choice restaurant. So the restaurant list builder send out the list of restaurants and then place the order. This is done. Restaurant employees should be able to find out Dasher. So Dasher service is providing that information. That's done. And user should be able to see the Dasher live location. So we talked about that. So now let's talk about NFRs. NFRs is like ultra low latency we talked about here. And user want to see the live location. So to do that, we have to store this information somewhere in a caching here. And this caching may be, we can use memcache as we don't want a persistent, it is just a live location. So I think memcache may be a good option, but we can use Redis also. That's fine. For this scenario, I will go with memcache. Generally what I do is like if it is persistent, I go with Redis. So it is like ultra low latency, definitely. And this service is like one thing which is like we didn't talk about, that system has to be highly available and scalable. So to do that, these all services we are talking here has to be stateless, which means they should not know about the session. And how we handle it, we have a service here, gateway, who is responsible for your auth and redirecting the requests to the right service. And here will be a session service. So gateway responsibility will be auth and redirecting, and it will take care of session also here. So these all services will be stateless, which means we can horizontally scale them up. So as the load goes up, and location services also will be accessed through the gateway. So the Dasher will also not be talking straight to the location service, rather it will talk to gateway, and then gateway will be reaching out to the location service. And they are highly scalable because multiple instances, and we have like horizontally scaled up as applications. So we need a load balancer also here, which will be in front of every application to balance the load. So now this is highly scalable, highly available, and ultra low latency, and the eventual consistency. So I think we covered all NFRs and the functional requirements here. So I think we are good with the design, guys. So thank you so much, guys. Please share your feedback in comments and please subscribe my channel. Thank you so much.